Hi, are you Michaela? I heard you're having an info session about vaccines.
Hi, yeah, I am. What's your name?
Alyssa.
Nice to meet you, Alyssa. Has anyone ever talked to you about what vaccines do in our bodies or why we need them?
No, I just know that they're advertised as disease protection.
Oh, okay. Well, you're basically right. And basically, what vaccines do, what vaccines do is that they expose your immune system to the disease that we want to protect against, and your body makes antibodies against them. And this helps so that when you do actually get infected by this disease, the antibodies can catch the catch the disease and basically stop it from infecting your cells.
The antibodies are like bounty hunters.
Yeah, basically. And the reward is staying healthy. So, did you have any disease specific questions?
No, not really. I was wondering, why do I feel sick every year when I get the flu shot? Am I getting infected with the flu and all the other diseases in the vaccine?
No, you're not getting infected. Your immune system is just responding to the disease information that's been presented, and it's making the antibodies, like I mentioned before. There are 16 diseases that we have vaccines to prevent against, like chicken pox. I know you've heard of that one, polio, Hep B, and tetanus. So, this shows all the vaccines that we have that are routinely scheduled. And And the different types of vaccines are a weakened virus. So that would be that the virus is basically weakened by chemicals so that they don't reproduce as much in your body, so you won't get a strong infection. Or we can inactivate the virus with chemicals so they're dead and they can't reproduce at all. And other times, if you look down at the brown box, they just take parts of the pathogen. So, like a toxin, which is tetanus, they would just scrub the toxin that comes from the bacteria and present it to your cells. Or with a virus, they, strip one part that has crucial information and shows it to your body. Now, with the genetic types of vaccines. For vectors, they combine the DNA of the virus with a virus that's not going to cause any infection. However, it shows your cells how to make an immune response to it. With mRNA, that just shows your cells how to make the proteins against the pathogen we want to protect you against. And with DNA, it's the same exact thing as mRNA, except it's just not translated yet. So that means it needs to go through a couple of other mechanisms before your cells actually know how to make the protein to protect against from the virus or bacteria or disease.
Okay, so it won't give me the disease, but I won't get poisoned from all the chemicals in there.
Okay, so that's a very interesting question. Yes, we do need chemicals. However, there's not a lot. So when you think about a vaccine, it is a fluid, and that's because the main ingredient is water. So that's just helping the vaccine get inside your body. And the active ingredient is the antigen. And again, most of the vaccines that we use or that we have in our bodies, they only have a very small amount of the antigen, and most of the time it's just a piece of the antigen, so it's not actually a full bacteria or virus. There are adjuvants which help your immune system attack the antigen in a stronger way, so it's actually supporting your immune system to mount that response. And then we just have the stabilizers, the which keep the antigen dead, basically, and it also prevents it from going bad, which helps it with storage, so that multiple people can get a vaccine and they're not just made for each person every single time. And then there's also just residual traces of substances. So many people are worried about formaldehyde, which is naturally found in the body. And we have such a low amounts of formaldehyde. It's basically just to rinse the vaccine off of any excess manufacturing traces of substances. And for adjuvants, aluminum is basically it's the most abundant metal on the earth. So it's in the air, it's everywhere, and it's also in our bodies. So we can find it in water as well. We're not adding anything extra to our bodies.
Okay, so you admit there's a few chemicals and pieces of a dead virus or bacteria. I know my body can handle it, but my sister just had a baby and they're telling her my 2-month-old niece needs like 4 shots at the same time. My sister asked for smaller doses and the doctor said no. I don't get it. Like, won't her immune system be too exhausted to work properly and make her sick?
Yeah, that's a valid concern. 2 months does seem like a young age. However, when children are born, they're exposed to many pathogens as soon as they enter the world. And to even compare the vaccines that we were getting from 1980s to now, there's only about 173 antigens that you're exposed to through vaccines. Meanwhile, there are so many antigens and pathogens and diseases that around the world on food, when you walk on your clothes, everywhere. So we're constantly being exposed and we'll just keep being exposed to more. We're only being exposed to 173 throughout our lifetime, especially from 2017.
Thank you for that explanation. But even if it's not harmful, why do we get vaccines if the symptoms aren't bad and people barely die?
Okay. So that's this is pretty serious question because natural infection could lead to serious and fatal diseases. So everyone knows that chicken pox is pretty harmless. You just get itchy, but it also leads to shingles, which is pretty painful disease. And it's painful. You break out in rash and it's very unpleasant, especially once you get older and your immune system gets weaker. HPV, human papilloma virus, it causes ovarian cancer in women, which is, again, if not caught early, can lead to fatality. And even rubella, one of those measles, mumps, rubella viruses. The reason why we vaccinate against it is because if a mother is infected with rubella while she's pregnant, her child can be born with congenital rubella syndrome, which affects their development and gives them a slew of health complications. Also, it's cost effective. If you get a natural infection, you may not die, but the treatment will be so expensive that if you get serious symptoms, that it won't be worth it to live through. You may even have to miss work and school. So you're losing out on a paycheck because you had to take some time off. There's also reduced transmission. So babies, elderly, and immunocompromised are protected from this. If you look at it, we want to make herd immunity, which is many people that can be vaccinated get vaccinated so that they can protect the ones that cannot, that have the weaker immune systems. So if you look at this graphic right here, if somebody had, say, measles, and they went to a country that no one had the measles vaccination, so many people would get it because it spreads very easily and quickly. However, take the United States. There's such a high vaccination rate that, say somebody comes into a state in the US and they have measles, it won't go very far because so many people around create a circle of vaccination protection. So it can't be transmitted to those severely at risk communities.
You've honestly given me a lot to think about, but I still don't trust those COVID vaccines.
Why not?
Doesn't the mRNA vaccine change my DNA?
No, not at all. I touched on it briefly at the beginning of my presentation. However, if I go a little bit further into it, Pfizer and Moderna are mRNA vaccines. And again, like I said, mRNA just codes for a protein for your cells to present. So it's coding for the protein on the coronavirus so that your immune system can make antibodies against those proteins. And it doesn't actually come into contact with your DNA. So your DNA, if you look to the right, is inside the nucleus. And it goes through transcription, which is basically making your RNA. And then once that RNA is totally transcribed, it gets packaged up and gets put into the cytoplasm of the cell. So this is now the mRNA, and it's ready to be translated or to code for the protein. So when mRNA enters your cell, it's only entering the cytoplasm and not the nucleus where the DNA is. So you have no chance of it getting changed or affected in any way.
But I heard even if you're vaccinated, you still get COVID.
You may. And this is, of course, if you are exposed. However, if you do get infected and you are fully vaccinated, that you have a less chance of getting symptoms, and you have a less chance of being hospitalized or even on a ventilator. So if you look to this graph right here, it shows that the people that were unvaccinated were 16 times higher to enter the hospital in 2021. And if you look at this other graph with the people down to the lower right, there were 117 people that were hospitalized with COVID. Now, 20 of them were fully vaccinated, and 3 of them had to go to the ICU. And for fully vaccinated that had to be put on a ventilator, that was 0. And that's basically because the symptoms that fully vaccinated people present are not as bad. So if you look to the x-ray of the lungs, if you look on the right side, those are COVID positive unvaccinated lungs. And that cloudiness is fluid. So this person is basically having a case of pneumonia. If you look to the left, what do you see? It's pretty clear, and this person is not having pneumonia, which is, again, the respiratory syndrome that coronavirus causes. So people are having lesser symptoms, and a fully vaccinated person would basically get just a headache, runny nose, or sore throat. And you also have the decreased risk, 5 times decreased risk of infection. Meanwhile, unvaccinated people have a 10 times likelier chance to be hospitalized and to die from coronavirus. So I know that was a lot of information, but do you have any other questions?
Where can I get my COVID shot?
Right here at all your local pharmacies and some retail stores as well. You can also go on to this website right here, vaccines.gov/search, and type in your zip code, and they'll give you a list of places that you can schedule your vaccine.